Hello everyone, welcome back to my channel. In this video, we are going to learn the chapter stacks in Python. This is a topic in grade 12 computer science and we are going to learn from the basics. So let's start. First, we need to discuss what is a stack. Now, a stack is a linear data structure. So, what do I mean by that? When I say linear, it means the elements are adjacent to each other. So, there is a relationship between the elements, and we call that relationship as adjacency relationship. So these kind of data structures which have an adjacency relationship are known as linear data structures, and there are many kinds of linear data structures like arrays, queues, stacks, etc. But we are particularly dealing with stacks because that is what is required for CPSC. So, stack is a linear data structure and also it works on a principle. The principle that stacks work on is known as LIFO. LIFO is an abbreviation for last in, first out. That means the element which is entered last will be the first one to be removed out of the stack. So to understand this, the best example is to consider a stack of books. Let's say there are 4 books. So I will show like this. So there are 4 books. So if you see, the first book to be kept is the blue book, and on top of the blue book I have kept the purple book. Then comes the orange book, and after that we have the red book. Now the red book is the last element that has been added to the pile. But when you are removing the books one by one, you can see that the red book is on top. So the red one will be the first book to be removed from the stack. So this concept is known as last in, first out. You can also say first in, last out, because the first book to be entered, that is the blue book, is the last one to be removed from the stack. So you could say LIFO, or you could even say FILO principle. And this is what stacks work on. Now, when we say stack, if you are defining a stack, you can say it is a linear data structure that works on the principle of LIFO. However, there is a proper definition, that is, it is a collection of data items which can be accessed through one end, and that end through which the elements can be accessed is known as the top of the stack. Now, in this case, when I consider a pile of books, the red book is considered as the top of the stack because that is the end of the stack. It is the last element. So if you want to remove elements, you have to remove the red book first. Similarly, if you want to add elements into the stack, you have to put it on top of the red book. So the red book is acting like the end of the stack through which any kind of data access can take place. Either if you want to retrieve data, or if you want to add data, or if you want to delete data from the stack, whatever it is done through the top of the stack. And the top of the stack is basically the last element. Now, we are learning stacks, and you might think, what is the difference between a stack and a list? Now, a stack is essentially a list. However, the key difference is the LIFO principle. That is, the last element to be added is the first one to be removed. That is the main difference. And if you want to add elements into the stack, you cannot add it in between the stack. But when you consider a list, let's say I'm having a list 10, 20, 30, 40. And let's say in between the list, maybe between 20 and 30, I want to insert another element 25. Now, this is not possible if you consider a stack, because we learned that data can be accessed only through the top, that means the last element. But if you consider a list, you are aware about the insert function. So in the insert function, if you're mentioning the index number and the value to be inserted, then that particular element will be inserted into the list at the specified index number. So lists are mutable, and they can be used to add elements through any point. So between any two elements, you can add the new element. But in stacks, you cannot add new elements anywhere in the stack. You only can add it through the top. That means you can only append elements to the stack through the end of the stack. I hope that is clear. So insert function does not work for stacks. Insert function is only for lists. So now I hope you understood the difference between stacks and lists. And this is very important because when we are writing the code for stacks, we always consider an empty list to be the stack, and we add the elements to that empty list. So often students might wonder what is the difference between a stack and the list. So I hope now it is clear. Even though it is considered as a list in Python, in the Python code, we cannot modify, we cannot add new elements anywhere in the stack. You can only add it at the end. Now, next we have to discuss the different kinds of errors that can happen. So there are two possible errors. One is stack underflow, and the other one is stack overflow. Now, stack overflow means if you're trying to add elements to the stack beyond the limit, that means beyond the number of elements that it can accept, then that is known as stack overflow. But in Python programming language, you know that lists are mutable and there is no limit to the number of elements that you can add to a list. So since we are considering stack as a list in the Python code, the stack overflow error is not possible in Python because the lists are mutable and you can add any number of elements to the list. But when you consider stack underflow is something that can happen even in Python, because stack underflow means if you want to remove an element from a stack containing 0 elements, that means if the stack is empty and you are trying to remove one element from it, then that is impossible because in the stack there is nothing. So you are trying to remove something from an empty stack. Hence, it will generate an error that is known as stack underflow error. So this you need to keep in mind because stack underflow will be included in the code when we are writing the code for pop and even for peak function. So now let us discuss the different kinds of operations which can be performed on stacks. So the next heading is operations on stack. Now the first operation is push, the second one is pop, the third one is peak, and the last one is display. Now display is simple. You are just printing the stack. If you want to display the elements of the stack, you can use this operation. The peak function is used to show the top of the stack. The peak function is for the top of the stack. If you want to print the last element of the stack, which is known as the top, you can use the peak function. The pop function will remove the last element. That means it removes the top of the stack. So the difference between peek and pop is peek will only display the top of the stack. It will not remove that element. But pop will display the element which has been deleted. And further, if you are printing the stack again, you will notice that the element which was displayed will no longer be there because it is used to delete or remove the last element. Display is just for printing the stack. And push is basically to insert an element. If you want to insert or if you want to append an element into the stack, then you can say that is known as push operation. Okay, now let's start with the code that you need to write. So, first, I told you whenever it is a stack based question, it is always best to declare an empty list. So, I have declared a variable called stack and I have assigned an empty list to it. Now I am going to write the different kinds of functions. Now the code for the stack questions will vary depending on what is the question. Sometimes in the question they will say that you have to consider a list which has been created, and from that list you need to insert some of the elements which satisfy a particular condition into a stack. Now, if it's those kind of questions, then you need to create two lists where one should be user defined and the other one should be empty. And whatever condition is specified, for example, if they say push all the elements which are divisible by 5. So then you have to see in the list which you have created, whichever elements are divisible by 5, you need to append it to the empty list, which is the stack. So that is the case that you need to apply if the question is saying you have to push certain elements from a list. Now, in the general case, if they're just asking you to push, pop, or perform the peek function on a stack, then you don't have to create two lists. You can just create one empty list and do all the functions on that. So first I'm going to show you the push function. Whenever you are going for these kind of questions, please apply functions because functions are very important in all the chapters of grade 12 computer science. And even though they may give you mark for just writing the code separately, but when they ask you to do two functions like perform push as well as pop, then it's always better to use functions because then you can declare two separate functions individually. So def push. Now inside this push function, I am going to first ask the element to be added. So I will write le is equal to int input, enter the element to be added. Okay, I'm not writing the full thing, I'm just writing enter the element. And try to make the code user friendly. So you can write everything in a professional manner so that it is quite friendly and the users will like your program. Then the stack that I have created is named stack. So I am going to append this element to the stack. Append function will add the element to the stack and it will be added at the end. And that is what we want the push function to do. And I told you insert function is not applicable for stacks because stacks are working on the principle of LIFO. Then I will write print le has been appended, or you can say has been pushed into the stack. So if you see the last line, it is not mandatory because it is not going to stop your program from working. However, that is something that makes your code more user friendly, and of course, the code that you are going to write in the exam will be checked in terms of user friendliness, because when we are creating an actual program which is going to be shown to actual users, you know that we would like the program to be user friendly. So try to make everything user friendly. Now, you can actually call the function immediately here. That is one way of doing it. But I always prefer to not do that, because you can use a menu driven program at the end, and using that concept you can call all the functions depending on the user's choice. So I will explain that at the end of all the functions. So I'm not going to call the functions right now. We will call it inside the while loop at the end. So now we will go to the next function, that is pop. So I have to write def pop. Now, first I'm going to check whether the stack is empty. The reason I'm doing this is because if the stack is empty, then you know that stack underflow error must be displayed. So I will first say if stack equal to an empty list. That means I'm checking whether the stack is empty. And if it is empty, I'm going to write print stack underflow. So this way, to the user, it will be shown that the stack is empty. Else, now if the stack is not empty, I am going to write you have to remove the last element. And you know, in lists, the function that we use to remove the last element is pop. So I'm going to write d is equal to stack dot pop. Now, why have I not just written stack.pop? Why am I assigning it to a variable called d? The reason is because we know that pop function returns the element which has been deleted. So when we are using the pop function, you have to use a variable, because you know variables are placeholders to store values. So the d variable that I have assigned here will store the value that the pop function is going to return, and the last element of the stack is what has been deleted. So that will be stored in this variable called d. So now I can write print D has been removed from the stack, or you can say has been popped from the stack. Next is peek function. Now peek function is actually very similar to the pop function. The if clause that we have written here is actually the same thing what we have written for pop. So if stack equal to empty, I'm going to write print stack underflow. So if the stack is empty, I will say stack underflow, because if the stack is empty, there is no top of the stack because there is no element in it. Now, instead of writing if stack equal to empty, another way you can write it is if len of stack equal to 0. So that is also another way. You are checking if the length of the stack is 0. That is also a correct method of checking the underflow error part. Now, if the stack is not empty, I am going to write else, and we are not going to pop the element because peek function is used to print the last element, not delete. So what we are going to do is I will just write print stack of -1, because you know the last element has an index value of -1. So I will write print stack of -1. So it will print the last element of the stack, and I will write is the top of the stack. Is the top of stack. Okay. So this is the code for the peek function. The last one is display. And yes, display has also been asked in the board exams, even though it is quite simple. They have asked it along with other functions like push or pop and so on. So display is very simple. You just need to print the stack. So I will write print stack is the stack. Now, I told you that we are going to create a menu driven program. So, I'm going to explain that. Now, for the menu driven program, you have to write while true. You have to use a while statement. Now, sometimes in textbooks, you can see that they will assign some value to a variable, and they will check whether that variable is equal to the value. Like, for example, they will write if C, so first they will assign the value y to the variable C, and then inside the while statement they will write while c equal to y. Now actually this is not necessary, because at the end this statement is going to evaluate to true, because C has been assigned the value y. So basically we are checking if y equal to y. So that is true. So instead of writing all this, the simplest way of doing the menu driven program is just writing while true. That means for any true condition, it is going to work. Now I am going to print the choices which are available in front of the user. So for example, the user can push an element. We have written the code to push an element. So I will write print 1, push an element into the stack. That is the first choice. The second choice is to remove an element. So I will write 2, pop the last element, or remove the last element. The word is your choice. You can use any word. Then the third one is to print the top. So you can write peek function. And then we also wrote the code to display. So I will write print for display. And you have to write another option. We have only written the code for 4. The last option is to exit from the program, because if the user wants to stop, if he or she wants to exit the program, then he has to call the fifth option. Okay, so now I am going to take the choice from the user. So I will write choice equal to int input, enter your choice. Now, why are we doing all this? I will explain now. So basically, the idea behind this code is I have shown all the functions which are possible, which can be performed by the user, and I have given specific numbers. So now the user has the options in front of him, and he will mention which number he wants to perform. So for example, in choice, if he types 1, then I am going to write the code to perform the first function. So like that, I'm going to check which function the user wants to execute, and that is the reason why I did not call the functions, because depending on the choice of the user, inside the, based on the choice, we will call the function which the user wants to execute. So now I have taken the choice from the user. So I will write if choice equal to 1. So if the user has entered his choice as 1, then we will be calling the push function. So I am calling the function inside the if statement. Then I'm going to write elif choice equal to 2. Then I will call the pop function. And elif choice equal to 3, I am going to call the peak function. And elif choice equal to 4, I am going to call the display function. And elif choice equal to 5, I am going to break, because if you want to exit the while loop, then you have to break from it. Break is a jump statement. It is a part of grade 11 computer science. Now, actually, you can stop with this because we have already mentioned the options which are possible. But if you don't want Python to generate an error, like let's say, for example, the user has entered the choice as 8 by mistake. Now, we have not considered the number 8 as one of the options because we have only given 5 possible options. So, Python will think that it is an error and it will display an error message. Now, that is correct because actually we have given the options available to the user, so there is no problem in that. But in case you don't want Python to generate an error, and if you want Python to display a particular message, then what you can do is you can include an else statement. Again, this is optional because you don't need to include else when you're writing elif. So I will write else. So if the user has entered any other number, then I will print a message for the user. So I will write, sorry, this is an invalid choice. Select a correct option. And if you want, you can write thank you. Again, the user friendly part is up to you. It's your creativity that matters for the user friendliness. So this is how you write the code. The reason why we are using this while loop is because you want the code to work continuously unless you print exit, because inside the exit statement, we have written break. So what will happen is it will stop executing the code when you are exiting, and the code will stop. But unless we are exiting from the program, the code will work continuously because we have used a while true statement. So I hope this is clear. This is all about stacks. Now, just one additional part which I would like to tell you. There are certain questions which may be asked in the exams where they will ask you to pop the elements repeatedly. So they will ask you to pop all the elements from the stack, and when there are no elements, print stack underflow. So, if such a question comes, if they are asking you to pop the elements, then what you have to use is you just have to write for I in range len of stack plus 1. This is the code. Now, why have I included the for loop? Because you want the code that we have written to be executed repeatedly. Now, how many times do you want it to work? You know that in the stack, let's say if there is a stack containing 5 elements, 1, 2, 3, 4, and 5. Now, I want it to pop the first element, second element, third element, fourth element, fifth element, and after removing the fifth element, you know that the stack is empty. So the question has told us to print a suitable error message if there is no element. So after removing the fifth element, you want to again you want this code to work again so that the underflow message will be displayed. So totally you want it to work 1, 2, 3, 4, 5 and 6. So you want the code to work 6 times. Now for the for loop, the starting index by default is 0. So from 0, if you want it to work, you want it to work 6 times. So it should work for the values 0, 1, 2, 3, 4, 5. So these are the numbers that I will be taking. Now, what is 5? 5 is the length of the stack. There are 5 elements in the stack. So why have I included a plus 1 here? I have told 5 plus 1. So the reason why I have written 5 plus 1 is because the stop value, the stop index in for loop is not considered. So if you are writing for I in range 5, then it will not consider 5, it will only work till 4. So that is why, since you want I to take the value 5 as well, I need to make the for loop as for I in range of 6. That means len of stack plus 1. I hope that is clear. If there is any doubt regarding this, please ask in the comments and I will clarify it. So that's all about stacks in Python. Thank you everyone for watching this video, and in case you have any doubts regarding stacks, please feel free to comment and I will surely clarify your doubts. So thank you everyone. Have a great day and stay tuned for all the further videos.